A very good day to all panelists. I am SEE PEI JUN and my supervisor is Dr. Lim Ka-seng. Today, the research topic that I would like to present is feasibility study on magnetic patch for repairing leaking steel pipeline. First of all, I would like to introduce the whole idea of the research. Background of this study is over time of oil and gas pipeline may experience defect or damage caused by several factors. The most common causes of damage are pipeline leaking, corrosion, burst, and explosion. Incident of pipeline damage can lead to pipeline failure that result in injuries and fatalities as well as financial loss. Therefore, repair work need to be done on damaged pipeline to prevent such failures. However, conventional repair work such as replacing damaged section may cause productivity decrease due to operation shutdown. In order to maximize the productivity, alternative repairware which magnetic leak sealing method is being explored to repair a leaking pressurized pipe. Hence, the purpose of the study is to propose a repairing method that can be done without any operation delays or stop of production. The problem statement of the study is challenges faced by oil and gas industry, such as a series of structural and operational issues including pipeline defects or damage caused by exposure to harsh environment has deteriorated over time. If there are no immediate mitigation measures, this may lead to pipeline leaks, which can causing major safety hazards. The most common causes of damage are pipeline leaking, corrosion, burst, and explosion. Incident of pipeline damage can lead to pipeline failure that result in injuries or fatalities as well as financial loss. However, conventional repair work such as replacing damaged sections can cost oil and gas company millions of dollars in lost revenue due to shutdown of production for extended period. Therefore, this issue is needed to solve to help the oil and gas industry to prevent temporary shutdown production for repairing works to avoid financial loss. Next, the objective of the research is to study the relationship between magnetic and ferrous force between different types and configuration of magnet that attached to various areas of steel through weighing tests. Second, the objective of the research is to investigate the relationship between magnetic and ferrous force between different types and configuration of magnet that attach to various areas of steel and subsequently convert into pipeline failure pressure through tensile tests. Next, the scope of study is to study what is the relationship between magnetic field and ferrous force of magnetic patch between different types of configuration of magnet that attach to various areas of steel. Hence, two experiments will be carried out. First, a weighing test will be carried out by using a 50 kg digital luggage weighing scale and steel plate. Second, universal testing machine and data logger will be utilized to conduct tensile tests. Two types of existing magnet will be used in the experiment, which are neodymium block magnet with a dimension of 50 x 5 x 5 millimeters and strong neodymium round magnet river fishing magnetic eye board with diameter 20, 16, 12, and 10. The significance of study is the thickness of existing magnetic lead sealing rubber is not suitable as permanent repair solution as it cannot maximize the duration of repair work, which can cause operation delays or stop of production. This is because permanent repair needs to work with composite rubber. Therefore, feasibility study on using magnetic patch in repairing leak pressurized pipe is carried out to provide a suitable design for leaking pressurized pipeline. A literature review and overview to oil and gas industry in Malaysia from an article of Fujama, Karim, and Urun is referred. Besides a statistical result of the US, Europe, UK, and PetroChina in pipeline failure frequency, causes, and consequences are comparatively analyzed in 2017. Another statistical analysis of failure consequences for oil and gas pipelines is carried out in the same year. Next, in 2019, the title of article of an overview of marine pipeline repair methods stated that in case of damage and leakage in the pipeline, in addition to the large loss in the product and significant economic loss, it also causes environmental pollution. An article related to the upstream and downstream oil and gas production from Carmel is reviewed. In 2020, a study of shutting down oil fields, a risky and expensive option, which stated that restarting production is reviewed. Next, I would like to explain further in research methodology. As mentioned before, two types of existing magnet will be used in the experiment. One of the magnet is neodymium broad magnet. 3 sets of neodymium broad magnet will be tested, which labeled as A, B, and C. Each set consists 5 pieces of neodymium broad magnet. However, unfortunately, one of the magnets, which is labeled as A5, is broken during the testing. Next, 2 sets of strong neodymium round magnet of each diameter 20, 16, 12, and 10 will be used in the experiment, which labeled as A and B for each set of magnet. 2 tests will be conducted in the experiment. A weighing test will be carried out by using a 50 kg digital luggage weighing scale and steel braid. In general, the digital luggage weighing scale is using force sensors to measure the load of an object. Thus, the digital luggage weighing scale is used to measure how many forces is needed for both types of magnet to detach from the steel braid as shown in the video. Average standard deviation and coefficient of variation of 5 times testing of each magnet will be taken, and the relationship between different types and configurations of magnet will be compared and analyzed through Microsoft Excel. Next, tensile tests will be conducted to determine how many forces is needed for each magnet to detach from the steel braid in the experiment. Universal testing machine is used to conduct the tensile strength testing, while the data logger is used to record the value of strength during testing. Ferrule force of magnet detached from steel braid can be determined and analyzed. Hence, the relationship between magnetic and ferrule force between different types and configuration of magnet that attach to steel braid and subsequently convert into pipeline ferrule pressure through tensile tests can be determined and analyzed. Since this research is exploring new methods, so this proposed method could be a new reference to future study. The expected outcome from this research may provide a suitable design for leaking pressurized pipeline if the relationship between magnetic field and ferrule force of magnetic patch can be determined so that the repairing process can be done without any operation delays or stop of production. Last but not least, the research contract is prepared to ensure that everything from the research is done on time. That's all from me. Thank you.